Today's video lesson is going to be on the Focus Standard, Grade 8, Expressions and Equations, Standard 3, dealing with operations with scientific notation. Our topic for this specific video is scientific notation, multiplying and dividing, and our essential question for today is, how do the rules for multiplying and dividing in scientific notation compare to multiplying and dividing with exponents? So take a moment, pausing the video if you need to set up your header, including today's date, set up your question column and your note column, and resume the video when you're ready to begin. I want to begin today with a couple of just tips about operations with scientific notation. So there's two parts, the coefficient and the power of 10, and each part is solved separately, and the answer is always checked for proper scientific notation. So here we go. Let's take a look. We're going to dive right in, looking at multiplying with scientific notation first. So I've laid out a problem here for us. So we have, for our first problem, we're going to look at 3 2/10 times 10 to the 4th being multiplied by 1 2/10 times 10 to the 3rd. So remember, we know that these two values are in scientific notation because they have the coefficient and the power of 10. So the parentheses is holding them together. There is no operation here, but when we write two parentheses next to each other, we know that we're multiplying. So all of the operations here are multiplying. So it might be helpful to look at it this way, dropping those parentheses, and you'll notice I color-coded it by the values that were our coefficients and the values that were our powers of 10. So we want to group it by like items. So since it is all multiplication, we can multiply the things that are easiest to work with together. So I've gone ahead and set that up here. So we can multiply our coefficients together because we know how to multiply these values. And because of our work with laws of exponents, we know how to deal with powers with the same base and rules for being able to simplify that. I've written that out here actually. In multiplying powers, remember we keep the base and add the exponents. So let's go ahead and do that. Either part, go ahead and then eventually do both. So go ahead and multiply 3 2/10 times 1 2/10. And then we're going to go ahead and multiply, following the laws of exponents, 10 to the 4th times 10 to the 3rd. And let's compare our work. So here you can see I've pretty quickly done the powers of 10. We keep the base, we add the exponents, so it gives us 10 to the power of 7. For some, it's going to be, you don't want to necessarily multiply like this, and it might be tempting to get a calculator, but these are pretty small values, so it's always a good idea to practice that up. So if you want to write it vertically, you can. And remember, we just take 2 times 3.2. and we get 124. Then we're going to put a 0 placeholder and multiply by the 1. And you get 320, and then you're going to add that up together. And you should get 4 44/100ths. Remember, we don't put the decimal point until we add this all up, and there's 2 digits behind the decimal point, so our answer has to have 2 digits behind the decimal point. So multiplying with our decimals there. So now we just need to put this all back together. So our final answer is going to be 4 44/100ths times 10 to the 7th. So this was our original problem. We solved it by multiplying the coefficients to get 4 44/100ths. And our powers of 10, we multiplied those together following laws of exponents for multiplying powers, and then wrote it all back out in scientific notation. So let's go ahead and try another problem. Let's go ahead and try multiplying again. So here's the next one. If you want to pause the video here and then check your work with mine, feel free to do that. So for problem number 2, we have 6 5/10 times 10 to the 10th. And 7 times 10 to the 31st power. So again, scientific notation times scientific notation, everything's being multiplied, so we could drop away those parentheses. Again, I've used the color coding. The purple is our powers of 10. This orangey brown color is our coefficients. So first we want to multiply together our coefficients, and then also multiply our powers of 10. So to do the coefficients, I went ahead and multiplied it this way, multiplied by that 7. 7 times 6 to the 6 and 5/10 gave me 45 and 5/10. Then multiplied my powers, keeping the base, adding the exponents. I got 10 to the 41st. So as I get ready to write my final answer, I can put it all back together again. My coefficient times the power of 10. So I get 45 and 5/10 times 10 to the 41st. However, the issue is that this coefficient is not in proper notation for scientific notation. Remember, it can't go past the ones place. So I have to move my decimal place over between the 4 and the 5, which is going to increase my power of 10. So my final answer would be 4 and 55/100 times 10 to the 42nd. So always important that as you're doing this work, your final answer is always in proper scientific notation form. So those are our two examples on multiplying in scientific notation. Let's go ahead and take a look at dividing in scientific notation. So the steps are going to be pretty much the same. I've decided to write it out as its fraction bar style here. So we have our 3 and 5/10 times 10 to the 9th, and 5 times 10 to the 6th. And we are dividing those. We're using the fraction form of dividing. They could have easily have used the division symbol, and we'd follow the same steps. So I've gone ahead and separated it, since we deal with it separately, into two problems where we're dealing with the coefficients, right? Basically just separated it here. And then dividing our powers of 10. And with our powers of 10, we can remember our dividing powers rule from laws of exponents. So 3 and 5/10 divided by 5 is going to go evenly 7 times. It's going to be 0 and 7/10. With our powers of 10, so I got 0 and 7/10 from dividing 3 and 5/10 divided by 5. When dividing, we keep the base, subtract the exponents. So we get 10 to the 3rd. So our final answer here, we need to check to make sure it's in proper notation. It's actually not, because your coefficient has to have at least a 1 in the ones place. So it has to be between 1 and 9. And so we have to move the decimal point over one place to the right, which is actually going to decrease our place value by 1, so it becomes 7 times 10 to the 2nd power. If you haven't done so already, let's go ahead and try our fourth and final problem. So we have 5 and 4/10 times 10 to the 12th being divided by 2 times 10 to the 20th. So again, we're going to separate this out, deal with each part separately. We're going to divide our coefficients and our powers of 10. So 5 and 4/10 divided by 2, well, half of that. Half of 5 and 4/10 is going to be 1 and 7/10. With powers of 10, we can subtract our exponents. So putting it all together, we're going to get 1 and 7/10 times 10 to the -8, because 12 minus 20 is -8. So it looks like we have our final answer, 1 and 7/10 times 10 to the -8. Our coefficient is in proper scientific notation, so we don't need to make any adjustments to our final answer. That is going to conclude our video for today on multiplying and dividing in scientific notation. Please take a moment to make sure that your notes are complete. You may go ahead and work on that summary if you'd like to, and come ready to do problems like this in class.